Hello everybody and welcome to another mystery box function challenge. In the purple box there is some mystery math and your challenge is to figure out what it is. You can use the link in the description if you want to try this out, and when you think you've got an answer, come on back and see if we get the same thing. All right, let's start with a 0. Okay, so 0 gives us -2. How about a 1? So there we're getting a non-repeating decimal, which is making me think square root function or maybe trig. Let's try a 2. Okay, definitely a curve. Another non-repeating decimal. Let's try a 3. And we're at -1.5 or 1.6 there. Let's try a 4. Oh, way down there to -4 point something. How about a 5? And almost to -5. And it's starting to go back up again, or it's starting to slow. It's slow down the rate at which it was dropping. Yeah, let's put in a 6. And now it's going back up. Okay, so I think this is a trig function. Let me just look at a couple of trig values. So let's put in an approximation for pi, 3.14. Ha. So at pi, we're basically at -2, which is where we were at 0. That sounds a lot like a trig function. How about pi over 2? 1.5 is pretty close to pi over 2, and there we're at almost at 1. Aha, so it looks like the very top of this thing. Let me just try a negative couple of values here, make sure something funny isn't going on. So -1.5, approximation for -pi over 2, and there we're down at the -5-ish area. And how about -pi here, -3.14? Okay, so this looks very much like a regular trig function, although a couple of things I think have been done to it. I think it's been moved down, and the amplitude, how high the crests and the troughs are, has been changed. And what that means is there's a multiplier on this thing, and there is also something subtracted at the end to move this down. It's not centered around the x-axis here, so it's been moved down, I think. But let's figure out what trig function this actually is first. So let's think about that. Um, so on the unit circle, remember we have an angle that we put in, and starting here, so at 0, we reach the point 1, 0, and the cosine is the x coordinate and the sine is the y coordinate. And then if we get to pi over 2, that's where you're at the point 0, 1. So that's where the sine is going to be the biggest. And as I look on this graph, so at 0, we're at -2, and at close to pi over 2 here, we're at the highest this gets, which is up at 1. So I think this is sine. This looks like sine to me. A sine would be back to 0 here. This would be the point -1, 0. So sine, the y coordinate is 0 at pi. And at pi, we're down again at -2. So here and here. So it looks to me like this whole function has been dropped down too. So I think we've got the sine of x and then a -2 to move it down, but also the amplitude is bigger. So we've got a multiplier out here. And let's just actually figure out what the amplitude of this whole thing is. So we've got the highest we get to is 1 up here, a +1, and the lowest we get to is basically -5. So from -5 to 1, that whole, so +1, that whole distance is 6. So, and the amplitude is how high it goes up and then how low it goes down. So it's half of that. So that would be 3. So I think we're multiplying by 3. Let's just verify that with a couple of points. If I put in pi, so the sine of pi is 0, that should just be -2, right? And it is. So pi and -2 right there. If I put in pi over 2. The sine is 1. If I multiply that by 3, I'd get 3. And then if I subtract 2, so 3 minus 2, that would be 1. And look, here I am right at 1 at pi over 2. So I think we got this. It's a multiplier of 3 to make the amplitude bigger, and then a minus 2 to drop it down. Let's go ahead and reveal that. Yeah, so 3 times the sine of x minus 2, and let's graph that. Kind of a cool looking graph. There's that sine wave, but going much higher and much lower than you would expect. Well, how did that go? Did you think, Trig, did these numbers tip you off? Let me know. Thanks, everybody.